Hey everybody, welcome back to the Dawn of Drones podcast. I'm Don Zolda, your host and the CEO of P3 Tech Consulting. We're in April and it is Thought Leadership Month. We kicked it off last week with our sponsor of the month, True Weather Solutions CEO, Don Bershoff. And if you missed it, you missed a good one. So go back and watch it on demand on Drone Life TV YouTube channel. And by the way, if you haven't subscribed to that, absolutely subscribe to that channel. But we are live today, and we have with us an incredible guest and a thought leader in his own right, my friend, my colleague from Boulder, Colorado, Dr. Jack Elston, the CEO of Black Swift Technologies. Jack, great to see you.
Yeah, good to see you. Thanks for having me on.
I know it's crazy we're in Colorado. At some point, we actually have to do this maybe together.
Yeah, that'd be fun.
And by the way, everybody out there, Jack is a repeat performer on the Dawn of Drones. He was with us last November in 2021 for Innovation Month. And once again, if you missed that, you could check that out on demand. I know I have that link that hopefully Mike Pahel, my Oz behind the scenes, is going to drop that in the chat to let you guys go back and check that out. We talked quite a bit at that time about Jack's extreme beyond visual line of sight UAS operations. And we're going to talk a little bit about that more today. We're really going to expand this conversation. So super excited to have you back, Jack. I know so much has happened even just since November for both you and your company.
Yeah, we've been working on a number of different projects, kind of getting pulled in all sorts of different directions, but it's been fun.
Yeah, and one of the things that you've done is you've become a Carahsoft partner. And for those of you that don't know, Carahsoft is a pretty ginormous government IT reseller in the United States, and they work exclusively with federal, state, local, tribal, territorial governments, and they have an end-to-end UAS line card solution, which includes now Black Swift Technologies and your made in the USA drones. So Jack, before we get into your drones, let's talk about you for a second, just to catch people up that may not know you. Just maybe that 30-second elevator speech background.
Yeah, sure. So Colorado native, oddly enough. Anyway, I got into aircraft at an early age. Really wanted to be an astronaut. Went to the Naval Academy. Turned out my eyesight wasn't good enough, so wasn't able to do that. But came to the University of Colorado and really got involved with unmanned aircraft systems. Ended up staying, doing a lot of skiing, and also getting a PhD in aerospace engineering. At that time, we were using a lot of different military hardware to do a lot of the flying that we're doing, just simply because that's all that was available. And the project we were working on was a really fun one. It was my PhD thesis, which was basically tornado chasing with unmanned aircraft. Anyway, after we got done with that, we said, hey, we can build a better autopilot system, something that's easily commercially available, that is simple to use, and kind of gets to the point of just, abstracting the aircraft out of the whole equation and just saying, this is where I want to get my data, go get it. And so we started basically in my living room with just a couple $1,000s between the two of us, making autopilot systems, and then eventually ended up picking enough contracts and interest that we developed our own full aircraft solutions. And so now we're one of the few companies in the world that designs pretty much every component. We do the avionics, we do the control systems, we do the communications, we do the vehicle design, we do payload integration, and we've even designed some of the payloads ourselves.
Yeah, and the we you're talking about is Dr. Machek Stachora. Is that right? He's the guy that was at your kitchen table as you were designing your first drones together. They're in Boulder, Colorado. So super cool. We had Machek on Clubhouse back in November, and it was he's such a neat guy, and it was really cool to meet him in person. By the way, Jack is one of the board members of UAS Colorado, and actually hosted, because it was Black Swift Technologies' 10-year anniversary, if I recall correctly, kindly hosted our holiday party last December, where I got to meet Machek and catch up with Jack in person. So really amazing. We've got such a great ecosystem here in Colorado, and obviously Black Swift is a big part of that. So let's talk about this drone. I mean, you just mentioned you create all the different components made in the US to, to your technology. But let's focus first on the drone and S2, that's the primary airframe that you created. Is that right?
Yeah, that's certainly our workhorse right now. We have a number of different payloads for it. We've used it for all sorts of different applications. The one you mentioned, we just recently went up to Alaska in September, flew nearly 25 miles out to a volcano, 7,000 feet up, 25 miles back, and then still had time on the summit to do all sorts of different surveys. That was in weather conditions that grounded, a helicopter. It would be tricky to fly through with a Cessna, and we were able to get up there and go get measurements in a very difficult region. And so we're pretty happy about the performance of the aircraft.
So everybody, Jack actually talked quite a bit about his volcano research with UAS Colorado during one of our meetups last year. That's on the UAS Colorado YouTube channel. Mike, I believe, has that link, and he can drop that if y'all want to save that and check that out later to have that deep dive on volcano research. But let's talk about how your uncrewed aircraft system can survive and thrive in these extreme conditions. What have you done to it to allow it to be so resilient to fly essentially on the side of volcanoes?
Yeah, one of the things I mentioned with the strong winds that we were dealing with, basically after we popped over a ridgeline, there was a very strong sideways wind component that was turning into a vertical component. It kind of rolled over the top of that ridgeline. And so it was actually pushing the aircraft down very strongly. We have a whole bunch of machine learning that basically is running on board all the time, looking at various different sensors and systems and trying to see, if things are going to struggle or if sensors are having trouble so that we can come back and safely recover the aircraft before anything really bad should happen. And one of the things we have been looking at is just the entire energy in the system. So, we're pulling energy out of the battery, putting it out through the prop, and hopefully generating lift and flying somewhere with it. We noticed once we got over the ridgeline at one point in time, or actually the aircraft noticed, automatically that was in conditions that it actually couldn't sustain flight in. And so sitting back in the ground, as an operator, you're trying to be diligent looking what's going on. And we just saw a bunch of different red warnings come up. And then all of a sudden it said like it was returning to base. And then it gave us the message why it was doing it. It was because it knew it didn't have enough energy basically to get over that ridge line. Wow. And really excited about that. It was one of the best things that could have come out of that entire campaign. Now, we didn't get out and go get the data, which was a little bit disappointing, but we got the aircraft back to go another day. And it was one of those complex systems where you put it together, you do the math, and it should work, but actually seeing it working was pretty impressive. And it's another step towards making these aircraft just another tool in, say, a scientist's belt, or anyone out there trying to do a job with it on an aircraft system. You don't want to have to be an aerospace engineer, understand all the different details of what's going on in the aircraft to be able to fly it safely. And so if it knows it itself and it's able to say, hey, look, I can't go into this region, here's why, that just makes it safer for everybody.
Well, it's amazing that you have designed all of this. I'm seeing a ton of chatter here, by the way, Jack. Chris Wedgeworth is one of our regulars. He said he's at work watching from Northern California. And Before You Go, which is James Stanton, he asked, are you having trouble getting chips? Because we were talking about this kind of made in the USA, around the kitchen table thing. Are chips a concern?
Yeah, it's one of my biggest issues right now. So my other role that I play, I'm the main electrical engineer at the company. And so I'm the one that usually has to deal with all these different fallouts from the suppliers. Yeah, chips, sensors, all sorts of different things. I mean, you name it. Every time we put together a board, it feels like 70% of the components aren't available and have like a 2-year lead time associated with them. Fortunately, since we make all our own stuff, we're able to be a little bit flexible. And so I can change designs to accommodate different components that have come out and are available to swap in. As you can imagine, it's not great. It takes a bit of time. It's one of the things too, where you see those components come up, you buy a whole bunch of them as much as you can. I think that's unfortunately making the problem worse, but I mean, there's only so much you can do to kind of hedge your bets on what's going on with these things.
Well, you alluded to this too, Jack, the fact that your S2 is kind of plug and play, right? It's modular. You can incorporate and integrate other sensors, things that you haven't personally built. So let's talk for a second about that because, by the way, everybody, Jack was on our Clubhouse last week, and Mike also has the link for that if you want to listen to that replay. we got into a whole bunch of stuff that we're not going to get into here, but a lot of thought leadership stuff since it is Thought Leadership Month, you know, about the Beyond Visual Line of Sight, ARC report, and, you know, some other things. So absolutely check that out. But getting back kind of to this plug and play idea, really exciting news, right? You just did a commercial launch for the first ever really kind of combined UAS soil moisture sensor package. Tell us about that.
Yeah, it's pretty exciting for us. It's been a project we've been working on since 2012, so it's been a long time coming. But it's a pretty tricky instrument. It's, you know, it's loosely based on a satellite technology that NASA's also put up as well, and they spent around $1 billion on it, and in fact, it's not entirely functioning. So I mean, it's a tricky problem to solve, and so it took us quite some time to not only build the instrument, get it calibrated, get it working, but then also it's so sensitive that all the different components on the aircraft potentially interfere with it. So we had to do a lot of work on the aircraft itself to kind of mitigate all the electric interference and just make it all work together. So it's awesome to see it finally flying. We've compared it against all sorts of different in situ measurements, so going around on the ground with a probe, basically taking a look at what's going on with the dirt. And then there's a tried and true method for soil moisture content, and that's just going and digging up a bag of soil, measuring it beforehand, drying it out, and then seeing what changed. So we did plenty of that as well. So a lot of groundwork to get it up and running, make sure it works well. And we just finally delivered the first one to the University of Virginia, who's going to be using it for calibration and validation of that satellite that I just mentioned from NASA.
Wow, super cool. And no pun intended, you know, the ground up or whatever you just said. So I want to break that down a little bit.
Sure.
Because you mentioned a problem or the problem. So let's first talk about the problem that you're trying to solve with this technology, because everybody, I did just write an article about this, by the way. It's going to be coming out in Drone Life later in the week, so keep your eyes peeled for that. I learned a ton, you know, talking to Jack, researching this on my own. The problem you're talking about and soil moisture has to do with what exactly?
There's all sorts of different things that soil moisture goes into, from weather models to flash flood predictions to agriculture. Agriculture would probably be the most obvious one, where if you could show, you know, you can maintain the same amount of crops or even increase them by reducing the amount of water usage. Obviously, that's a huge thing, especially now with, you know, for instance, the drought here in Colorado. So it's one of the things a lot of people are looking into. Certainly soil integrity, I mentioned, you know, flash flood prediction, or there's also landslides. If you can tell how much soil moisture content's within the ground, you can better predict landslides. There's also a bunch of different construction aspects to it. So you're taking a look at whether you can move heavy equipment across an area. You know, even trains kind of suffer from now and then derailments and things like that because of the integrity of the soil. So having that information is key for a number of different areas.
So the problem, so that is definitely a solution to a lot of different market sectors, right, that need to understand the content of soil moisture. Your product is unique insofar as it is, my understanding is, it is the first of its kind. And prior to what you just created, we were relegated to using satellite imagery only. And why is your solution, why does it have more fidelity or is better than satellite imagery alone for this purpose?
Yeah, so the NASA satellite, it's called SMAP, is still pretty impressive for what it does, even though a part of it's not working. They'll still give you worldwide coverage at 30 kilometers a pixel, basically. So fairly large pixel size, but worldwide coverage, which is very cool for taking a look at all sorts of like global effects. However, to get down on kind of like a regional level, to do things that actually are going to impact precision agriculture and things like that, obviously you need a lot better resolution than just 30 kilometers per pixel. So our solution allows you to get down to, at least right now, about 5 meters per pixel, and then we're further doing additional work to kind of reduce it beyond that.
And it's literally to the root level. I mean, in other words, it's not just surface, like topography type information. It's actually subsurface.
Right. The current incarnation of it penetrates, and it depends on the soil type, but usually about a couple inches at least, down to about maybe 3 or 4 inches. So not quite root level for some crops, but Yeah, it penetrates the top of the soil. We have other stuff that we're working on right now that allows us to get even further, say up to a couple feet below the surface. But for now, we're starting with this is still kind of a one of kind measurement. I mean, other than looking at the satellite data, which is you have to wait for the satellite to come around, so it's not always available when you need the measurement, and it's also really coarse resolution. The only real other way to do it is to either install sensors in the ground that sit there permanently, and then those can measure quite a bit down into the soil and give you a nice temporal scale on that, but they take hours to install. They're in the way of everything that you're doing, and then you have to pull them out if you want to go harvest the crop or do whatever else you want to do with it. The only other option too is just doing these hand measurements, which are incredibly tedious. You just have to walk around with an instrument, push it down into the soil, tell it to take a measurement, and continue on to the next point that you want to take that. It takes a very long time to cover an area. So if you want to get an idea of what's kind of happening across like a field scale, there's really the only way to do it is with the unmanned aircraft system when we put it together.
Well, and just to kind of foot stomp this, you and your team actually designed this soil moisture sensor, and as I believe you said, it's been 12 years in the making. You've had tons of flight time testing and proving this out to the point that now you've commercially launched it. So that's super exciting when you think about all the issues you mentioned and sustainability. I mean, look, Jack, it was essentially your neighborhood that incredibly in December was on fire. I mean, a wildfire in Boulder, Colorado, in a in a residential neighborhood in December, like, has been unheard of, until now. So can you explain how this technology can also be applicable to wildfire, kind of prevention, mitigation, even recovery?
Sure. I'm certainly not going to claim to be an expert on wildfire mitigation and stuff like that, but we are working with several different groups. One of them is the USGS. We're flying over a site in California, which notorious for fires as well, where we're providing them with the soil moisture product along with a bunch of different vegetative indices so that they can tell what plants are there, what the soil moisture content looks like. And we're doing it several different times around the year so they can see during the wet season, the dry season, and use that to plan out how they're going to actually, if they're going to do trimming, if they're going to thin some of the trees out, if they're going to, put in certain fire breaks, how they want to plan for fire. And so it's a fairly interesting project to talk with them about how they'd actually use this information to better mitigate what might happen should a fire start.
Yeah, I just, I'm sorry, I squirrel sometimes because I see things pop up in the chat. And this month's sponsor, True Weather CEO Don Bershoff, is in the chat right now saying, satellites measuring soil moisture with insufficient resolution is the same problem in seeing low altitude micro weather for drones and eVTOLs. It takes an array of sensor capability. I love Jack's work. I would love for the two of you to get together, because when I think of the work you do, Jack, with this extreme kind of weather events, tornadoes, hurricanes, volcanoes, wildfires, and I think of what Don is trying to do with this sensor ecosystem to basically crowdsource as much data as possible to fill that desert, the data desert for low altitude micro weather. What a match made in heaven you two would be. So if I haven't made that connection yet, because it's all blur, I will make it. But I could see just an amazing partnership with their with your sensors and your technology plugged into his system. I think it would help everybody. And by the way, Dan Julin is out there from Canada, Arium. Dan's with Arium, and actually he's going to be on the podcast as a Carahsoft partner in June, which is Emerging Leaders Month. They've got a cool robird that's doing really neat things, their company. But anyway, he says, great to hear from Black Swift this week. I'm a huge fan of STOL, basically, short takeoff, vertical takeoff and landing. Such cool technology. The temp limits are almost unbelievable. And I agree, Dan, what Jack is doing is pretty unbelievable. So let's talk. I mean, let's pivot from the soil moisture and all of these different applications now with this commercially available product. Before we do that, I'd be remiss not to be clear on what the package is. Okay. So first of all, it's your S2, STOL, short takeoff and landing, vertical. And or no, yours launches. It's launched right now.
Right. Yeah. So we're working on the vertical takeoff and landing variant. We've done a lot of testing with what's the second iteration of it so far. So that should be ready soon. But right now it's a pneumatic launcher and belly land.
Okay, so you've got the vehicle, the sensor, and what else about that kind of comprises this UAS soil moisture package that you're now having out there commercially?
Right. So with the radiometer, we're able to measure L-band reflection, so basically energy reflecting off the ground, and then kind of look at the difference between that and what's hitting the aircraft directly. And we get information about the water content through that entire path, but there's a lot of other different things that contribute to that. There's the plants, there's the soil type that actually adds to the reflectance. There's a ton of other things that we have to kind of throw at this equation. So we also cover the entire area with a high resolution multispectral thermal camera, and then pull all those things together along with several different databases to give you the soil moisture product. So there's quite a bit that goes into it beyond just the technology that's flying around on the aircraft.
Because when I read through your website, Jack, as I was preparing your article, the article for Drone Life, it did harken back. It reminded me a lot of True Weather and their True Flight solution with the way you can kind of see how the weather is crowdsourced in an easy to read kind of go no go chart for operators. You have a bunch of different, I'll call it patented, I think, right, or at least trademarked systems. Can you kind of walk us through those? I remember on your website there were like 3. Is this for you, Bell? Okay. I'm going off script here, everybody. So Jack's bearing with me.
You're talking about the different payloads for the S2?
Yeah, the different payloads, like the different kind of functionalities that Black Swift brings to the table with the vehicle.
Yeah, I mean, the S2 was designed from the inception to be all about the sensor. So we kind of designed the vehicle around the sensor. And so we maximized payload size and weight that we could carry for an aircraft that would pack down into something you could actually still take on a commercial airline, because we have to be responsive to events like volcanoes and things like that. So we can't wait for it to be shipped somewhere. We have to take it with us usually. But in doing so, we made it so that we can carry a lot of different things. And with all these different cool applications we've done, we've had opportunity to develop all sorts of different payloads. And we do particle sizing and distribution, which is very interesting over fires or volcanoes, as you can imagine. We do trace gas measurements. So again, volcanoes very interesting. Fires, we can give them idea of like what types of gas are contained within what's being burned right now, so they can give warnings downwind to people in communities that might be at danger from breathing in some pretty bad stuff. We've also put in a number of different cameras. I mean, as I'm sure a lot of people that work with unmanned aircraft are familiar with, there's options from RGB cameras, thermal cameras, multispectral, hyperspectral, kind of spans the gamut. We're even looking at putting in what's called a mass spectrometer. So being able to take in the air and use a very complex method to figure out everything that's contained within the side of it. So you can tell which types of gases there, what kind of particles are in there. I mean, it's this amazing piece of technology. So we've integrated a whole host of different things, and they all have their nuances, and they're all fairly tricky to put into an aircraft, whether it's the weight, whether it's the fact that it's got to survive launch and landing, and those are somewhat high G events, or whether it's simply just interfacing with it, because a lot of these instruments are designed to be things that are handheld. And so you have like a screen and a battery and all these other things. So it's always a new fun challenge to put together. But we have a whole suite of very interesting instrument packages that you could do all sorts of different things. And we're excited about the fact that it kind of pushes the envelope of what can be done with unmanned aircraft systems. I mean, rather than just specifically looking at the things that are being done today, we're looking at stuff that, in a couple of years from now are going to be the things that are primarily flown on unmanned aircraft systems. So we're pretty excited about that.
Yeah, so fun fact, when I was just a major in the United States Air Force, I actually worked for the drug lab. And so I'm very familiar with gas chromatography, mass spectrometry, GCMS. That's what we use to do the drug testing. So when you said mass spectrometer, it brought my brain back to those times. It was interesting assignment to be sure. But Dan Julin is asking, does the S2 have any onboard detect and avoid systems?
So we always conclude ADS-B in. with all our different aircraft, just so you have that situational awareness. For people that aren't familiar with it, it's basically a radio broadcast that manned aircraft send out that we're able to pick up from quite a ways away. I mean, 50 miles, it kind of depends on the area, but it's a long ways away. And we're able to see where the aircraft is, what their speed is, what their altitude is, and basically from that, determine if it's going to be something that we need to worry about and get our aircraft out of the way from. We've done a lot of work with NASA as far as airspace integration for obstacle avoidance and detection, as far as doing that in an automated way, whether we put together a system where the vehicle itself can actually identify areas where it's safe for it to land, which with a multi-rotor or VTOL, I mean, I guess that's somewhat trivial. You just pick a spot on the ground that's big enough that you can set down in that doesn't have obstacles nearby, but you still need to be classifying things. You need to say that's a person, that's a car. Don't get nearby those things. For belly landing solutions, which is what we were looking at as well, you can imagine it's fairly difficult to pick out a corridor that's long enough, doesn't have any obstacles in the way, and is also aligned well enough with the wind that you're not trying to fly downwind and land, going with the wind. So we've done a lot of work in those areas. The only really active thing that we have on the aircraft right now is the ADS-B, because most of the time we're flying missions where we're up high enough that obstacles aren't an issue.
Yes, you're up high enough, but maybe some of these agricultural solutions and beyond visual line of sight. I could talk to you offline about some folks that I work with that might be a good fit, but great question, Dan. And Jack, what I was talking about, I pulled up your website, by the way. So I remembered reading it. I just didn't remember what it was called. You have a thing called Swift Pilot, Swift Tab, and Swift Station, all trademarked.
Right.
So, and Mike, there's a link there, if you wouldn't mind dropping that, if folks want to kind of surf through Jack's website and check this out for themselves. So tell us about those three products that are integrated into your holistic solution, not just for soil moisture, but for all of these different applications you're talking about.
Yeah, and apologies for the naming convention. That's all Machek. I had nothing.
No, you know what? It actually resonated in my brain. I knew there were three of them. I knew there was a trademark. I just couldn't remember what they were until I looked it up. But no, I think it's catchy and it's easy to remember, even though I'm sorry I didn't put it in my notes. But Swift Pilot, Swift Tab, and Swift Station.
Right. Yeah, so we started, as I mentioned, putting together autopilot solutions. That was our first product that we put together as a company. This is while the code that now composes the thing that's called drone code nowadays is still a bunch of individual research groups and hobby groups kind of working on their own thing. So out of necessity, we had to come up with our own solution. So we call it the Swift Core FMS, Flight Management System, which kind of encapsulates everything. But the Swift Pilots are avionics. We took a very unique approach to how we did the avionics. We made it more distributed. Usually you think of an autopilot as just this one box that sits in the middle of the aircraft and does everything basically for you, and then has a couple of sensors coming in, actuators coming out. We actually made it so there's intelligent boards all over the aircraft. They're working with the sensor, with the actuator, and that enables a number of different things. One of it, you can do detection of what's connected to you. So like if a wing disconnects, a surface disconnects, something like that, you can see that that's automatically gone out. And if you plug in a different wing, for instance, you can actually figure that out too. So you can start doing things like lifetime tracking. And so you can do it's a lot easier to do maintenance and things like that. It also enables, I mentioned, we're using machine learning on board to take a look at all the various different subsystems and make sure something's not going wrong with it. And while it might be easy to just monitor current going out to a motor or something like that and say, hey, this doesn't make sense, there's a lot of stuff that's fairly complex. That the problems only manifest themselves by looking at all sorts of different things that are happening on board the aircraft. Say icing, for instance. Icing is one of those things it's notoriously difficult to detect unless you have something where you're actually actively looking at a surface and seeing whether it's icing, and you don't know how much that's affecting the performance of the aircraft. One of the unique aspects of unmanned aircraft systems as opposed to manned aircraft is there is this question of whether it's worth the risk to continue an operation because you're getting good science and then potentially lose the aircraft. Whereas with a manned aircraft, that's never a question, right? You always want to get the aircraft back and safe.
Yeah.
So it gives us a way to kind of take a look at something as complex as icing and say, like, how much is this affecting all the various different parts of the aircraft? Can we continue going? Do we need to turn back? Things like that.
Wow, that's awesome. And then Swift Tab, it's your flight planner basically.
Yeah, we designed, again, out of necessity, we designed these all from the ground up. So we have our own user interface. It runs on a ruggedized tablet, but you can use it on a bunch of different other things. That's the primary thing we do since we're usually out in the field in remote locations. But what we've done is we try to make it as simple as possible to go get your data. I know a lot of the other ground stations out there throw a ton of different information at you. That's kind of come down with a lot of people that flew manned aircraft and transitioned to unmanned aircraft and want every bit of information available to them. And you can do that with our stuff, but we generally try and hide that. And the main reason is we only want to bring that to attention when it matters. And so we use a lot of different automatic processes in the background, a lot of visual cues that are simpler, like icons, coloring, and things like that to make it a lot easier to fly the aircraft. And as kind of an example of that, we put in what I think is a unique system where if something goes wrong with the aircraft, generally it's not just one thing failing, it's usually several different things that fail. And if you're just sitting and looking at a ground station and just all these warning lights are going off, you don't know what to address first. It's just kind of a very stressful situation. What we do is we decide how much risk goes to the aircraft for each different failure that happens, and then kind of assign a level of how risky each thing is. And then we categorize those for you so that only the thing you need to address right now comes to the forefront. And so it pops up a window and says, like, you've had this failure happen. And it gives you two easy to choose from selections that you can do. If it's a warning that's just kind of, hey, you can continue your mission, but this thing doesn't look great, you can always dismiss it as one of the options. And then the other one, it gives you the best possible action to take. If it's a critical thing, it'll tell you either I'm going to do this thing unless you tell me not to do it, or do this other thing. And so it makes it much simpler to deal with these situations. So it just pops up the thing you need to deal with now. You can take that action and then move on to the next thing that needs to be dealt with. And it kind of just walks you through the processes to safely get that aircraft back into a good configuration.
Wow. And the ground station you're mentioning is also called your Swift station, where all these bells and whistles are going off, and the AI is kind of running in the background and giving that very specialized information to the operator so as not to overwhelm them. Wow, super amazing. So speaking of amazing, you've got, I believe you were just recently nominated. Black Swift Technologies was nominated for an AUVSI Excellence Award this year. Can you tell us a little bit about that? And if you know, like, what the submission was about for that category?
Sure. Yeah, we're pretty excited about that. That's again relating to the work that we did with the volcano observations, which hopefully will continue in the future. We have some plans with the USGS to continue to provide these observations for not only the US but all over the world. There's a lot of different places, particularly say Indonesia, where there's huge population centers very close to volcanic activity, and they don't have the means to constantly monitor them in the way that they need to be able to give effective warning for not only volcanic activity, but also the various different emissions that come out of the volcano can be very deadly and you can't see them. And so we can give them early warning for those kinds of things. So the submission was basically on the work that we did in Alaska, which, as you know, are two different components. One was actually going out and making valuable scientific observations of this volcano when manned aircraft were unable to get out there and go do it. So that was pretty exciting for us. And then the other one was, it was a pathfinding beyond line of sight mission. So, and as you know, proving out cases where BV loss makes sense, and this is why we've got to get in the regulations to allow us to continue to do these things. This was a great example for why BV loss matters. And so, those two things combined is basically what we submitted for. So the award that we're up for is for, I think, public safety.
Awesome. That is really exciting. And speaking of volcano work and some of the places you're doing that, before we were live, Jack and I were talking, and you're going to Costa Rica in about 3 weeks after AUVSI, is that right?
Yeah, that's correct.
And so I was going to say, what's the project you're doing there vis-a-vis volcanoes in Costa Rica?
It'll be the second time we've been down there. We're working with a group at Caltech and JPL. They have a really interesting application where they're looking at how CO2 affects plant life. So normally when they're studying how much plants are affected by CO2, they've done it in the temperate zone just because that's where all the money is available. And they have to erect these big poles that inundate them with CO2 over several years. And then they take a look at the plants and how much that's affected them. But in the tropics, where they haven't had that much money to put in that kind of infrastructure, it's kind of largely unknown. And the tropics are one of the best producers of oxygen. And so what we've done is gone down there and mapped entire volcanoes to take a look for where there are vents, because the volcano will actually outgas a number of different gases. One of those is CO2. Now, you don't want other gases in the area, say SO2, that will kill the plant life, because then that's just negatively affecting that. You can't see the effects of the CO2, but there are vents where it's mostly just CO2 coming out. The question is just where. It's a very dense jungle. It's hard to just send people to walk around and figure out where that is. And so we spent several days mapping the entirety of a volcano, which, as you can imagine, is tricky. There's not always good access. It's, sometimes it's very limited as far as roads. The roads themselves aren't great. Thick jungle. But with all the different systems we put together to fly these aircraft safely beyond line of sight, we're able to go out, map at a fairly low level above the tree height, and then get CO2 content coming out of the area. And then they can take a look at that, take a look at those maps, and decide which areas they want to send people to go take a look at the plants underneath and see how well they're surviving in a CO2 rich environment.
Wow. So for those listening, if you're not like, holy shnikes, this guy and this company are incredible, this is exactly why he's here for Thought Leadership Month, because it's not just, Jack Handy deep thoughts. It's all about the work you're doing that is contributing to this body of thought leadership around, drone applications to the environment and to weather in particular, which is again right up Don's alley. He keeps chatting over here about icing and especially for larger cargo drones being a big challenge, and they're doing some work with AFWorks on that. You're working with NOAA, I believe, and continuing your work with the P3 and hurricanes right after the Costa Rica trip. So I don't know when you have time for all this, Jack, or when you're actually home, but tell us about the P3 integration and what you're doing there.
And by the way, before I get that too, we're meeting with Don next week, and so we've been chatting with him all along. His products are awesome. We're very excited to work with him, and as my focus in my PhD was doing atmospheric science with unmanned aircraft systems, we're really excited to work with True Weather. So that's coming up.
Awesome. Yeah.
Very good solution.
Well, very
as
good.
far as the hurricane integration, in a couple weeks here, I'm flying down to Lakeland, Florida to go work with NOAA to integrate our aircraft with their P3. We've got a couple of the initial prototypes for a tube-launched aircraft that we're going to be dropping out of the P3 over the Gulf, and basically taking all sorts of different readings to make sure everything's functioning correctly. We're doing comparisons between all the different instruments that are on the P3 to make sure that we're measuring accurately what's going on with the atmosphere. So yeah, it's pretty exciting. It's the preliminary work that we're doing to make sure that everything's safe, everything's working, everything's going well, because we're going to be heading back down there during hurricane season to actually be deploying several of these into storms.
Well, just incredible. And I do want to pivot a little bit since it is thought leadership, maybe a little bit of that Jack Handy stuff. Jack, your products are made in the USA, and was it you, by the way, that was on the unmanned aircraft conference yesterday, the online conference?
Yes. Yeah.
Okay, I thought it was you. I was like, Jack E, that's got to be Jack Elston dropping these comments. So for those that didn't know, Military Embedded Systems put on a one-day event. I hosted the keynote with United States Marine Corps Captain Shelby Ox, who is the co-program manager for Defense Innovation Unit's Blue UAS program that a lot of people here are familiar with. But if you're not, it's basically a way that it's a third way, as Shelby explained it, for companies to become part of the federal government ecosystem of cyber secure and trusted drones in the face of some legal bans in the National Defense Authorization Act, Section 848, fiscal year 20, and other policy bans that preclude the use of a whole range of foreign, Chinese, other countries' drones and their components. So I know that's been, challenging, and I was asking some probing questions of Shelby yesterday, because it's just like, what, is this a rolling, ask for people to say, hey, pick my drone, like I have one, even though I didn't make the cut on Blue 1.0 and Blue 2.0, which was the most recent effort? The answer was no. At least that's what I heard. And they're looking to maybe have a more regularized system and kind of working through the bureaucracy that is the Department of Defense. Having been there for 30 years, I get that. So if you had a recommendation, again, deep thoughts here, recommendation, to Defense Innovation Unit, being kind of one of those folks trying to break into this ecosystem, because there are other ways to become a part, right? Program of record, exception to policy, some other transaction authorities, just harder, takes longer. What would your recommendation be, just from where you sit?
To people that are trying to break into the space, or to, I guess, Shelby and
people like you that are trying to break into this space. I know it can be frustrating, and I imagine, at least from where I sit too, now that I wear a media hat that I didn't wear when I was with the government, there's somewhat of a lack of transparency, I think, on the selection process, and also even the requirements because they put them up and take them down.
Right. Yeah, the requirements are fairly vague too. It's based on whatever customer the DIU has. They put up a couple of bullet points, put down their slide deck to try and respond to it. Maybe or maybe you don't respond or resonate well with them. It's hard to say with a slide deck, and there's no real feedback. And so I, certainly understand that frustration. With Shelby too, he had certain clients, government clients, that paid for that work to be done. And unfortunately, they had some unintended consequences that he's gotten a lot of questions for recently, and I kind of feel a little bit sorry for him, because he's always having to explain away, like, look, this wasn't our intention. But basically what's happened is groups like, say, the Department of the Interior that don't have their own certification process are looking to other people to be able to certify these aircraft and say, this meets a number of different criteria, and cybersecurity certainly being one of them. And so they just adopted that they could only use aircraft coming out of the DIU's lists. Well, they weren't one of the groups that paid for the original one, at least. And so it made the people using the UAS very angry, because those aircraft honestly were not intended for the use case that they were looking for. It made groups outside that very upset, because, hey, why wasn't I part of this group that got to, these small amount of aircraft that got approved? And by the way, there's no other further approval process to go through. There are other approval processes, though, fortunately. We've been through 7 or 8 different NASA flight safety reviews, are incredibly in-depth processes, making sure that everything's on the entirety of the system, the payload is all ready to go, your safety cases are covered. You've even looked at all sorts of little nuances of the area. In fact, one of the safety reviews we were on, we were doing the soil moisture flights, and those are a little bit lower than we normally fly. They had us citing the regulations for how tall a semi truck could be to make sure that we were going to be outside of the, anywhere near flying over a semi truck.
Wow.
But once we got through that, and then we have the approval to be able to operate within NASA. And NASA is one of those entities for ever we've been looking at for airworthiness, and all different qualifications for aircraft. So certainly that could be a way forward, both as a certification group for developing standards for like what's safe for an unmanned aircraft system, but then also it is a way right now currently to be able to get into these federal spaces. Unfortunately, each entity kind of decides that on their own. With NOAA, we had to go through a completely different process where they, instead of just approving the particular application that we're doing, they approved the platform and said, like, the S2 is safe to be able to use for NOAA applications. Each and every one kind of has their different process right now. So while that's a little bit unfortunate, there is opportunity there in the fact that you can go to a number of these different entities and get your aircraft approved, and then hopefully take that approval that you get with you to do any sort of other federal contracts and say, hey, look, this meets all the cybersecurity requirements. This meets the requirements that nothing was manufactured in any of those banned countries, and so on and so forth.
Yeah, and some states are now creating their own kind of blue UAS requirements and whatnot, or at least proposing that. So a lot of wickets to go through, but we only have just a couple minutes left, Jack, and I want to make sure people know how to find you. So first of all, the next place where people can see you live, and oh, by the way, see Captain Shelby Ox live too. Talk about that in a second, is at AUVSI Exponential in Orlando, Florida, April 25th through the 28th. You're going to be there Monday for the weather event. Is that right?
Yeah, that's correct. Yeah, we have a really exciting panel put together for that one. A lot of people are giving some very interesting information about flying aircraft in difficult weather conditions.
Yeah, super bummed that it kind of bumps up against my one-day Law Tech Connect workshop that I'm holding. Just had a panel discussion this morning with one of our panels. But Shelby is going to be on the panel at the end of the day, if you can swing by, Jack, with AFWorks, with General Post moderating, Mary Caitlin Ray, an amazing attorney that used to work with the FAA, now with Crowell Mooring, leading up, spearheading their aviation group, doing great things. And also Asalon, who's made it through the wickets with AFWorks. So that idea of public-private partnering is what that last panel is all about. But we are, oh my gosh, we are at time, Jack. People, how can they reach you? Other than running around the expo floor, I know you're going to be there Tuesday as well. So
Right.
find Jack, as he's running around the floor. How else can they find you?
And feel free to message me. I check LinkedIn every now and then. You can email me easily. It's elstonj@vst.aero, arrow, as in like aerospace. Yeah, happy to answer those things, or just come by our shop. If you happen to be in Colorado, happy to give a tour. So.
Yeah, absolutely. And there's some great breweries up there and distilleries, just saying. So anyway, just real quick before we go, tomorrow, Clubhouse, 11 a.m. Mountain Time, we're going to have our podcast guest for next week on Skywatch AI. So when you think about trends and risk management, Skywatch, frankly, is the thought leader when it comes to drone insurance. So absolutely meet us on Clubhouse and then join us next week, same time, same place, with Skywatch, our guests. And then, Law Tech Connect workshop, you'll see a slide at the end here with a $100 promo code. Please join us. We're within that 14-day window. We've got a pretty good crowd, but we'd love to have more folks fill in seats, and we'd love to have you there, see you in person. And last but not least, very shameless plug here. I found out yesterday that I've been nominated for an Air Awards People's Choice Award. There goes Mike putting that up. Vote for me. I'm so excited. This was really unexpected and kind of made my day on a Tuesday. So thanks for putting that up, Mike. And that's all she wrote. Thank you so much, Jack, for being here. It's always a pleasure. I always learn so much talking to you. Look out for his article at the end of the week on drone life, and absolutely get in touch with him. So anyway, we are out here. Thanks, everybody. Fly safe.
Yeah, thanks. It was fun.